Alright, in this video, I'm going to teach you the concepts of finding cumulative distribution function for a continuous random variable with this probability density function. Alright, okay. I'm going to teach you how to find the to construct, okay, or to find the cumulative distribution function. So, okay, look at this function here. This is a PDF, right? Probability density function. So if you want to find the cumulative distribution function, so I will show you the step-by-step approach, okay, how to find the cumulative distribution. So very simple. So you just draw a line. This is for guidance, okay, for guidance, okay, so that it won't confuse. So 0, 3, 5, and 15, right? So they are value 0, 3, 5, and 15, right? 0, 3, 5, and 15. So means there is actually how many interval here? So we're using all the number here, 0, 3, 5, and 15. So we draw a line, all right? So there is 5 sections in this line, all right? 5 sections in this line. So the first one will be the before 0, right? We usually will say before 0. Okay, and later on 0 reach 0 but before 3, all right, before 3, and for this is 3 include 3 but before 5, all right. So and for this will be 5 but before 15, and this interval is 15 and beyond, all right, 15 and beyond. So if you see that this number line here, all right, I try to divide them to 5 sections here by using all the boundary value here, 0, 3, 5, 15, all right. So each section you have 5 sections here, you have its own fx, right, fx. So if you look at here, only this interval, only 0 to 3, the fx, right, 0 to 3, the fx is 1/8, right? And 5 to 15, the fx is 1/16, right? As described by here, 5 to 15, so it's 1/16. The rest, otherwise means beside these 2 intervals, right, your fx will be 0, right? Your probability density function will be 0, and here also will be 0. First, you have to identify this. You have to clear about this, all right? You have to clear about all this. So means that for this number line, so the probability density function for different interval have different value, right? For example, 0 up to 3 is 1/8. 5 to 15 is 1/16, right? Otherwise means other than these 2 interval, all is the probability density is 0. Okay, this is very important during we finding the cumulative distribution function. So okay, now you have to really pay attention. Okay, so now I go for the first interval, right? For the first interval. So before that, okay, I forget. Before that, I have to introduce you. Cumulative distribution function. Cumulative distribution function is using the capital letter F. Compared to this is probability density function, and this is cumulative distribution function. So and is defined to be integration from -infinity up to x, right? -infinity up to x. Okay, for a probability density function dx. Alright, so and the capital letter fx is also can be rewrite as probability of x less or equal x, right? The capital letter fx, the cumulative, is also rewrite as probability of x less or equal x, and this is the definition, right? For cumulative is from -infinity up to fx. Okay, now how to using this definition in finding the cumulative distribution function? It will take a bit long time, all right? So it's time consuming to construct, so please pay attention. So now we're using the first interval, right? The first interval where during x less than 0, at this moment your capital letter fx is defined, right? We follow the definition. It's from negative infinity up to x, right? Negative infinity up to x. But look at this interval here. The fx, right? The fx here. So during this interval, x less than 0, your fx is 0, right? Integrate 0. So integrating 0 for a probability is actually giving you 0, right? Giving you the value of 0. So now, this is for the first interval, right? First interval, I have find that my cumulative to be 0. So now we have to go for the second interval. Alright, let's look at how I finding the cumulative for the second interval. So the second interval will be for x, just follow this. I have done with this, right? I done with, now I go for the second interval. So which is 0, x less than 3, right? Okay, now fx. Fx. So the fx here, I starting from negative infinity. Okay, pay attention here during this part here. Negative infinity, not up to x yet, because it's already passing 0. Because I have already done with the first interval, means it's already passing 0. So it should be reached 0, right? 0. And negative infinity up to 0. During this time, your fx is 0. Alright, your fx is 0. Later on, I need to continue. Because now I have already go to second interval, so I have to start with 0 again, but not reaching 3 yet, okay? During this interval, so I put 0 up to x, alright? 0 up to x. So during this interval, your fx is defined to be 1 over 8. 1 over 8 dx, alright? Okay, then I have to integrate this to find the cumulative function for the second interval. So let's see how I do this. As you know that this will be 0, right? This will be 0. And if you integrate, this will be 0. So if you integrate this, you are getting x over 8, right? X over 8. Okay, go slowly, x over 8. So from 0 up to x. So you substitute the x, you have x over with 8. Alright, x over with 8 minus away 0 over with 8, you are having 0, right? So that's your answer for cumulative distribution function for the second interval. For this interval, your capital letter fx, the cumulative function will be x over 8. Right? So this is for second interval. Now we have done with second interval. Okay, pay attention again. Alright. Now we go for the third interval. Right? So you see how you see the pattern, right? The pattern. So the third. So the third is interval 3, between 3 and 5, right? Include the 3. So now your cumulative distribution function. Pay attention here, right? Now you see, I start all over again, negative infinity, up to, means I start all over because I accumulate, okay? I accumulate. So then negative infinity up to 0, negative infinity up to 0. During this time, your density function is 0, and followed by integrate. Now, second interval I already tick, right? I already tick means that I have to integrate everything from 0 up to 3, not stop at x. Okay, we are not stopping at x. So during this time, 0 to 3, the density function is 1 over 8 dx, right? Plus with, now focus on this part here, all right? This part here. So now I have to, now because I going to the third interval, right? Going for the third interval, so I have to start with 3 up to x. Can you see? I always stop at x. Stop at x. Stop at x. For the third interval, 3 up to x. So I stop at x. Third interval, right? So for the second interval, I stop at x from 0 up to x here. Alright? So you try to see the pattern. So 3 up to x. Right, during this time, during this interval, what is your fx? your fx is 0, right? Fx is 0 otherwise. So it's 0 dx. So now I'm going to teach you very simple. So it's from negative infinity up to 3 here, all right? Up to 3 here. So for these two, for the first two, right? For the first two, you can actually rewrite it to be a capital letter F3. Capital letter F3 to tell you that this is the probability before 3, all right? Probability before 3. So x less or equal 3. And plus with the current interval 3 up to x, 0 dx. And now this value, you have to substitute to the function, the cumulative function before. It's easier, right? You substitute this cumulative function value to the one before, right? Before this is the second interval. You substitute inside here, this function here. So you are getting 3 over 8. 3 over 8 plus with the current one. So the current one will be, if you integrate 0, you are getting 0. So means that for the third interval, your cumulative distribution function is a constant, right? It's a 3 over 8. All right, if you not very understand, now you go for the fourth interval because we have already done with the third interval. It's not easy to understand this. You have to really follow, see the pattern. All right, number 4. Now we go for the fourth interval. Remember, we go for the fourth interval. So then fourth interval will be 5x 15, right? So what is your fx here? What is your cumulative here? So again, I need to start all over again. Okay, start all over again from negative infinity up to 0, right? First interval up to 0. During this time is 0 dx plus with 0 up to 3 because it's already past. Okay, I already tick. All right, now I add the fourth interval, right? So the first 3 I go and put a tick. All right, so I put 0 up to 3. So this time is 1 over 8 dx, right? 1 over 8. Okay, now I have ticked this, right? Because I want to find the 4. I tick, so means I integrate from 3 up to 5. Okay, plus 3 up to 5. So this time is 0 dx, right? 3 up to 0. And now, you see carefully, fourth, right? The fourth means 1, 2, 3. The fourth means that the one that now I am doing, the current one. I never put a tick. So means that I have to start with 5 up to x. Stop at x. All right, stop at x. And what is the function during this time? It's 1 over 16, right? So I put 1 over 16 dx. All right, okay. Now you see, for the first 3, right? For the first 3, 1, 2, 3. For the first 3, I can rewrite this 3 as the cumulative before 5, right? The probability before 5, right? The probability accumulate before 5. So F5 because it's ending at 5, and this F3 is ending at 3, right? So now plus with the current one. The current one will be 5 up to x, right? 5 up to x. So I'm integrating this, all right? Now I'm going to integrating this. So 5 up to x, integrating 1 over 16 will be x over 16, right? From 5 up to x, right? So see carefully. What is F5? What is F5? F5, you have to substitute to the one before, right? But there is independent of x, right? There are no x here, so you you cannot substitute. You just take the value, right? You just take the value 3 over 8, all right? 3 over 8. So you're taking 3 over 8 plus with the current one. So you're putting x, so you have x over 16, right? X over 16 minus with 5 over 16. So rearrange again. So you take 3 over 8 minus 5 over 16. So I'm getting 1 over 16, negative 1 over 16. Alright, for here I'm getting negative 3, I get 1 over 16. Or I can just write 1 over 16 x minus 1. Alright, now I have already done, listen to me, I have already done with interval 4. Finally, I go for the fifth interval, right? So, okay, this is the cumulative function. Okay, look at this. This the last one, the function here is the capital letter fx for the fourth interval, right? Now we go for the last interval, right? Now we go for the last interval. You see carefully the pattern here, right? So the this interval of x greater or equal 5. So what is your cumulative function here? You have to start all over again. So it's a proper way, all right? This is a proper way of doing, all right? So negative infinity up to 0. Then during this time, it's 0 dx. Same like what you do here, right? Same like what you do here. You just copy back, all right? Then you start from 0 up to 3, right? 0 up to 3. So during this time, it's 1/8 dx, right? Plus with again, right? Again, because you have 4 tick here, right? 4 tick here. So 0 up to 3. So now is the third tick, 3 up to 5. 3 up to 5. During this time, it's 0 dx. Plus again, from 5 up to 15. Now it's 5 up to 15. It's already tick, right? So 5 up to 15. Okay, 5 up to 15. The function, the cumulative, the property density function here, right, is 1/16. So 1/16 dx. And finally, right, finally, because this is the fifth, right, it's the fifth, so you must have 5. 1, 2, 3, 4, 5 integral. And the last one must be 15 up to x. Must be 15 up to x. I not tick, right? So 15 up to x. So now during this time, your probability density is 0. Your probability density is 0. Okay, again, right, repeat the process. You look at the first, from the negative infinities, 10, 3, 5, up to 15, right? Before this is up to x, so we don't look at this. So everything here up to 15, right? So it's written as capital letter 15. The probability, total probability before 15. So plus with the current one is integrate 15 up to x 0 dx. So what to do with this 15, right? This 15 you have to substitute to the cumulative function. This one, see carefully, this one you put to the one, the fourth, right? The cumulative before, so the fifth you use the function, right? This one before, all right? For this f5 you put to the one before, right? And for this you put to the one before, right? So like that. So then you're putting 15 here. You're putting 15, right? So you're putting 15. You are getting. All right. Sorry, I have to do some correction. You look at here, right? I hope you realize actually 308 minus 5/16. 308 minus 5/16 is positive. Sorry. All right. Human always make mistake, right? So positive here also, positive 1. Suppose it's x plus 1/16. So when you put the 15, inside here, right? You put the 15 plus 1. 15 plus 1/16. Definitely, if you integrate 0 for a probability function, you are getting 0, right? You're getting 0. So at last, what do you get? The most important is 15 plus 1, 16/16. At last, you are getting 1. This is the most important one. Okay, I have to put a 5-star here. Finally, you must getting a 1. If you get a value other than 1 or greater than 1 or less than 1, something wrong with your calculation here. So, okay, this is the way we construct the cumulative distribution function. All right. Okay, now I'm going to summarize this, all these function into an interval. All right. Please jot all this down. Look at it. All right. Okay, now I'm going to rewrite this into a piecewise form. Alright, now I'm going to summarize for you. Okay, just you can play back the video to see the process again. So now I know that for during the first interval, right, your cumulative is 0. Second interval, your cumulative is x/8. So I have list down everything for you. So now, so I have to rewrite this. This is a probability density function. So and the cumulative density function, we are using the capital letter fx, and it's always this is the special, as I already tell you teach you in discrete random variable, if this is a capital letter fx, a cumulative, it will always start with 0, right, and end with 1, right? This is the difference between cumulative distribution function and probability density function, okay, because it starts with 0 and end with 1. So we actually accumulate the probability. So during the first one will be 0, right? So when x less than 0, okay, when x less than 0. So followed by the second interval. So the second interval is 0, x, but before 3. So during this time, the fx, the capital letter fx, right? Your capital fx will be x over 8, x over 8. So later on, for the third interval, 3x, but before 5, right? So during this time is 3 over 8, right? 3 over 8, 3 over 8. Okay, now third interval, and the fourth interval, 5 less than 15. During this time, your cumulative will be 1 over 16, right? 1 over 16, x plus 1. All right, this is for 1. 1 is for the interval, the fifth interval, which is x more or equal 15, right? So this is very important, okay? I have already it's quite long, difficult. No, it's quite tedious, right? From the small fx to big fx here, because you need to do some integration for 5 interval, right? So then this is your final summary. So where you have summarized this in the form of piecewise function for a cumulative distribution function for this continuous random variable. Alright, so in the next video, for the same question here, I'm going to tell you how to using the cumulative distribution function to finding the probability, right? As I already teach you how to using the probability density function to find the probability in the previous video, right? So now in this one, I'm going to introduce you how to using the cumulative to finding the probability. So let's see in the next video.